In this part of the data structure course related to stacks and queues, you will learn what is stack. We will declare and implement a class for stack, and then through an example, we will use stack to check if a given string is a palindrome. A stack is a data structure consisting of a list of items and a pointer to the top item in the list. Items can be inserted or removed from the list only at the top. That is, the list is ordered in the sequence of entry of items. Insertions and removals proceed in the last in, first out order. Initially, stack is empty and top is initialized to -1. Notice that the array index is starting with 0. Because of that, -1 is used to represent empty stack. If item A is pushed into the stack, top is incremented by 1 and it becomes 0, and in that location, A is stored. Then B is pushed into the stack, it is stored in the location 1. Top was 0, it is incremented by 1, and in that location, B is stored. Then by the push C operation, top is incremented, it becomes 2, and C is stored in that location. If an item is popped from the stack, the one at the top is taken from the stack, so the output is C. Meanwhile, the value of the top is decremented by 1. Top was 2. After pop operation, top becomes 1. And notice that the top item is removed from the stack by the pop operation. If another pop operation is applied, then the top item was B. It is removed from the stack. The output is B, and top is decremented. It becomes 0. If then D is pushed into the stack, top was 0, top is incremented by 1, it becomes 1, and in that location, D is stored. Here is the code for the stack class. The IOStream operations is included by this header, and also standard library is included. A constant integer is defined, which has name max stack size, the size of the array in which the stack items are to be stored. And it is initialized to 50. We have a template class implementation here. Because of that, we are saying that template class T. Here, T is a generic class name, and then it will be replaced when the stack objects are declared according to their types. And this is showing which type of items are to be stored in the stack. In the private part, we have the stack list. It is an array of max stack size defined here. And the type of the elements in the array is T. Another variable, private variable, is top. It is integer. This is showing the position of the top item in the stack list. In the public part, we have the constructor stack. It has the same name with the class, and there is no input for the constructor. And also notice that we are not writing anything for the return type of the constructor. In the constructor, the top value is to be initialized. We have also some modification operations. Push operation is to store an item into the stack at the position shown by top. As a parameter, we have an item. It is of type T. However, here notice that we have a reference and it is constant. If we use reference here, when the function is called, no memory is reserved for the item. Because this is a template type, we do not know what is the size of the type T to be used when the push function is called or when the stack is declared. Because of that, we are using reference, and then to indicate that this is not going to be updated, we are writing here constant. And also notice that by the push operation, we are only changing the content of the stack. This item is stored into the stack. There is no return value from the push operation. The pop operation is to get the top item from the stack. There is no input, but there is a return value here. It is of template type T. Clear stack is to remove all the items from the stack and it becomes empty by the clear stack operation. No need for an input and there is no output. And we have another operation which is called pick. It is just copy top item without modifying stack content. So it returns the top item, but the top item remains also in the stack. It is not deleted from the stack. There is no input. There is a return type T. Because the content of the stack remains the same, this is a constant function. There are two operations to check the stack state. One is stack empty. This is checking if the stack is empty, and accordingly it is returning an integer. If it is empty, it returns 1, otherwise it returns 0. Because the content of the stack is not changing, but this operation, it is constant. And the stack full checks if the stack is full. It's a constant method because the content of the stack is not changing. It returns 1 if the stack is full, otherwise it returns 0. No input is required for the stack full operation. This is the end of the class. And now here we are implementing the stack methods. Again, the implementation is in template type. For the constructor, this is a constructor for the class stack of type T. This is the name of the constructor, same as the class. There is no input parameter as in the declaration. The only operation is that top is set to -1 in the constructor. That's all for the constructor. Now let's consider what is to be done in the stack empty method. A function is called method if it is belonging to a class. So we can call stack empty or the other functions as method of the class stack. This is the stack empty function. So it is the stack empty method of the stack class. It is belonging to the stack class of type T. It will return an integer. There is no input and it's a constant method. Here we have a return statement in the implementation. Here the implementation starts with this curly parenthesis and this is the end of the method. Here it is checked if top is equal to -1. If this is true, the value of this expression is 1 and this returns 1. Otherwise, the check top equal to -1 returns 0 here, and because that value is returned, then return from the stack empty is 0 if top is not equal to -1. So if it is empty, it returns 1, otherwise it returns 0. Here the value is 1 if top is equal to -1 and 0 otherwise. The other method is stack full. Again, we have template implementation. It is belonging to the class stack of type T. The name of the function is stack full. There is no parameter and it's a constant method. This time we are checking if top is equal to max stack size -1. Notice that the last location in the array is max stack size -1. If top is equal to that value, that means that if a new item is going to be stored into the stack, there is no more place. Stack is full. We are checking if top is equal to this one. If it is so, it is returning 1. Otherwise, it will return 0. Here we have the implementation of the push operation. This is template implementation. This is belonging to the class stack of type T. The name of the function is push. There is an item here as the parameter of type T. There is no return value. We cannot push a new item into the stack if stack has exceeded its limit. So we have to check first if stack is full. If stack full, remember that this function will return value 1 if it is full. If it is the case, here the message stack overflow is sent to the error device. Usually the error device and the output device are the same. They are the monitor. And then we have a new line here. After the message, the program will exit. And the exit code is 1 as shown here. This is the if part. If this is not true, if stack is not full, in that case, the value of the top is incremented by 1. And in that location, considering the new value of top, in the stack list, the item is stored. And this is the end of the push operation. This is the implementation of the pop operation. This is the method for the stack class again. The name of the function is pop. There is no input. And we have output of type T. Here we are declaring a temporary variable temp of type T. If stack is empty, there is nothing to pop. So we are checking stack empty. We are calling the function stack empty. If it is so, there is an error message at the error device saying that stack is empty, end line, and exit from the program. If stack is not empty, it continues. The item at the top of the stack list is stored into temp, this variable temp, and then the value of the top is decremented by 1, and whatever the temp value here is returned from the pop operation. This is the return type, and temp is returned. This is the end for the pop operation. Pick is the same as pop, except top item is not moved. Template implementation. This is for the class stack. The name of the function is pick. There is no input and it's a constant method. It will return an item of type T. You can write pick as an exercise. And the last one is clear stack. Again, it is a method for the class stack. And there is no input, there is no output. It's a simple method. It only sets the top value to -1. Now we are going to write a program that uses a stack to test a given character string and decides if the string is a palindrome. That is, reads the same backwards and forwards. For example, K-A-B-A-K, kabak, or a man, a plan, a canal, Panama, etc. These are palindromes. They read the same in the backwards. The algorithm is as follows. First, get rid of all blanks in the string, then push the whole string character-wise into a stack, then pop out characters one by one, comparing with the characters of the original deblanked string. Assuming that the stack declaration and implementation are in stack H. Include stack H and also include iostream_h. This is from the library. Here we have a function, the blank. Notice that this is not a method. This is not belonging to any class. This is a function only. The inputs are character pointer s and character pointer t. Here s is the input. In fact, all the blanks will be removed from the string and it will be loaded into string pointed by t. While the item pointed by s is not null, so we continue here while the character is not null. If this is not end of the string, we continue. In the while loop, we are checking if the item pointed by s is not blank, and if it is not a blank, the item pointed by s is stored into the location pointed by t. We are copying the character in string s to string t. T is incremented here, if it is the case, if we copy it. In any case, s is incremented. Notice that this is incrementing the content of the pointer by considering the size of a character, which is a single byte. After all the characters in S except blanks are copied into the string T, to inform this is the end of the string, we have to append a null. So the item at position pointed by T is set to null. We append null to new string. In the main part, we define true as 1 and false as 0. These are integer constants. And then we create stack object to store string in reverse order. In the main part, we are defining constant integers, true and false, initialized to 1 and 0. We are creating a stack object to store string in reverse order. Stack is declared as character. S is the name of the stack. Also, we have the character arrays, pass string having length 80 and dblank string having length 80 also, and also a character C. We have is palindrome declared as integer and initialized to true. We will stop if the value of is palindrome is false in the loop. We get input by the cin statement. On that one, get line is applied. Into pass string, the input is read, at most the length is 80, and to the end, slash and the null character is inserted. Then the function dblank is called. It removes the blanks in the pass string and it is stored into the blank string when the blanks are removed. Then by considering each character in the dblank string, it is going to be stored into the stack. We are using an integer I, this is string array index, while the blank string I is not null because we will have a null at the end of the string that the user entered from the keyboard. On the stack S, we apply the push operation. We are calling the push method, where the character stored at the ith location of the array, the blank string is the item. This is stored into the stack. And the value of I is incremented by 1, so we consider the next character in the blank string. So all the characters belonging to the string up to null character are stored into the stack. Notice that when we enter the characters into the stack one by one, if we get the characters from the stack by the pop operation, then the order of the characters will be reversed. Now pop one by one, comparing with the original. We are again setting I to 0. While stack is not empty, we continue in the loop. You notice that on stack S, we are applying the stack empty method, and by this symbol, we are applying the not operation on the result. We get a character from the stack by the pop operation. It is stored into character C. Get out loop when first non-match. If C is not the same as the blank string at position I, if they are not same, we are saying that is palindrome assigned value false. And we break the loop because we are sure that it is not a palindrome. That is, in the forward and backward directions, the strings are not the same, so they are not palindrome. If there is no break, we continue until the end of the string. Each time I is incremented by 1 in order to consider the next character in the string, and we get the next character from the stack by the pop operation. Then we get out of the while loop either by this break, in which case is palindrome is false, or this never happens and we continue till the end of the string and the value of the is palindrome is still true. The operation is finished. We print out result. Then we check the value of is palindrome. If this is true, here there is a cout statement. The string that the user entered by using the keyboard sent to the output device, and after that it is written is a palindrome and it goes to the next line. In the other case, if is palindrome is false, that is this case, it is set to false. Again, the pass string is sent to output device, and then it is written that it is not a palindrome, and it goes to the next slide.